Assalamu alaikum class. In this video lecture we will discuss about inductive effect. What is inductive effect? Inductive effect is actually polarity. It is polarity in sigma bond due to electronegative atom. Electronegative atom or electron withdrawing or electron donating group. Actually, inductive effect is caused due to difference in electronegativity or any group which has the ability to withdraw electronic density or any group that can push or donate electronic density toward any chain or carbon or any other atom. For example, here is alkyl halide and I am writing chlorine, Cl. Chlorine is electronegative atom and it has ability to attract electronic density toward itself. So the electron between carbon and chlorine will be attracted toward chlorine atom and chlorine become partial negative. In this case, this carbon has to face electronic deficiency, so we can say that it will bear partial positive charge. And if this carbon is bearing partial positive charge, then it also has to attract electronic density from this carbon atom and electronic density will be pushed toward chloride as this carbon will become less partial positive charge and least partial positive charge will be on this carbon atom. We can say that the inductive effect decreases when the chain increases. Some silent features about inductive effects are this effect is permanent. This is permanent effect. This effect causes due to electronegativity difference. Causes due to electronegativity difference. When the chain of any alkyl group increases, the inductive effect decreases. We can write it as by the increase in the alkyl group chain inductive effect decreases. Inductive effect decreases. How many types are there of inductive effect? We can categorize it into two types. First is positive inductive effect. And second is negative inductive effect. What is the difference between positive inductive effect and negative inductive effect? If we have group that is electron donating in nature, if alkyl chain or any molecule has a group electron donating nature, electron donating nature, then the inductive effect caused due to electron donating nature of the group is called positive inductive effect. For example, alkyl group like CH3, CH2, etc. These all are electron donating groups due to which there is a formation of positive inductive effect. In case of negative inductive effect, alkyl chain or any molecule has a group having electron withdrawing nature, having electron withdrawing nature, then the inductive effect caused due to that group which have electron withdrawing nature will be negative inductive effect. That will be negative inductive effect. For example, Cl, F, Br, NO2, etc. These all are electron withdrawing groups. Now moving toward some application of inductive effect, I am going to erase this part. Application of inductive effect. Applications of inductive effect. Now moving toward first application. First application is the stability of carbocation. Stability of carbocation. There are three types of carbocation. First are primary carbocation, second are secondary and tertiary carbocation. How they are stable? Primary carbocations are least stable, then secondary carbocations are least stable, then tertiary carbocation. Why tertiary carbocations are more stable? Now going to elaborate their structures. Here is primary carbocation. If the charge is on terminal carbon atom, the cation will be primary, or only single carbon having positive charge, that will also be primary carbocation. In this case, here is positive charge, and I am going to write a methyl group. It is also primary carbocation, and it is least stable among all alkyl cations. In this case, CH3 is pushing electronic density toward carbon atom, and this positive charge being compensated a little bit. But in this case, when we have secondary carbocation, carbon, CH3, hydrogen, CH3 and positive charge. In this case, two methyl group are donating electronic density to carbon atom, and there is decrease in positive charge of carbon. We can draw it as electronic density being pushed toward this carbon, and this electronic density is being pushed toward this carbon. In this case, this carbon have positive charge, and that positive charge is almost minimum due to electron density in between these two carbons. In case of tertiary carbocation, there are three electron donating groups. There are three electron donating groups, CH3. This CH3 is pushing electronic density toward carbon. This is also pushing, and CH3. In this case, the positive charge on carbon will be minimum as compared to secondary, primary or methyl. So tertiary carbocations are more stable among all these carbocations. Next is strength of acid and bases. First of all, strength of acid. Strength of acid. Organic acid. For example, we have a carboxylic acid having an R group. We can analyze its strength by this group. If alkyl group has electron donating group, or if this group have electron withdrawing group, there are two possibilities. If a group is attached toward this chain, has nature of electron donating, and second possibility is that if this alkyl group has a group attached that have ability to electron withdraw. If alkyl group has electron donating group, then we can say that the acid will have weak strength. The acid will be weaker. Acid will be weaker. Why acid will be weaker? I am going to explain it with the example. We have formic acid. Here is formic acid, and here is acetic acid. Now look at this. It is weak electron donating group, and CH3 is stronger electron donating group as compared to hydrogen. So it pushes electronic density toward carbon, and electron will be available for hydrogen to be stable, to be attached with the carboxylic group. In this case, this carbon is more partial positive. Electronic density is being attracted toward oxygen, and it becomes more partial positive, and it becomes partial negative. And these electrons come toward this oxygen, and this hydrogen is readily available and can easily be lost in the medium. So formic acid is stronger acid than acetic acid. In this case, if electronic density is attracted toward oxygen, this carbon becomes partial positive, but this methyl group also gives electronic density to carbon atom. So this partial positive charge is less as compared to this partial positive charge. So in case of acetic acid, it becomes weaker because CH3 is electron donating group and stronger electron donating group as compared to hydrogen. I think you have taken the concept of electron donating group. In case of electron withdrawing group, if any group is attached to or having electron withdrawing nature, then acid will be stronger. Acid will be stronger. Acid will be stronger. For example, we have ethanoic acid. Ethanoic acid, CH3 oxygen OH. Acetic acid or ethanoic acid. And another we have chloroethanoic acid. Chloroethanoic acid, CH2 C double bond oxygen hydrogen. Here is one Cl chloride or chlorine atom. Now compare these two acids. In this case, chlorine will attract electronic density of CH2 group toward itself, creating partial positive charge on CH2 group. In this case, the electronic density of this carbon also withdraws towards CH2, and these electrons come toward this oxygen, creating more partial positive charge on hydrogen. And hydrogen can easily be lost in the medium, making this acid as a strong. And in this case, CH3 is pushing electronic density toward carbon, and electron between oxygen and hydrogen are available, so hydrogen will be attached with oxygen atom. In this case, chloroethanoic acid is stronger than ethanoic acid. Now moving toward the strength of bases. Strength of bases. Strength of bases. For example, we have any amine or NH2. If we substitute hydrogen atom in ammonia with any alkyl group or electron donating group, then we can say that electron donating group will increase the basic character of any compound. In this case, the alkyl group, if this alkyl group is electron donating, or this alkyl group is electron withdrawing. If we use electron donating group, then it will increases the basic character of that compound. We can write it as increases the basic character of a base or any molecule. If we use electron withdrawing group, it decreases the basic character. Now I am going to discuss about electron donating group. Suppose R group is electron donating, then what will happen? This R group will push electronic density toward nitrogen atom. According to Lewis, any base having donatable lone pair, or a base has ability to donate its lone pair, then it will be good base. When electronic density is pushed toward nitrogen atom, these electrons will be readily available. If electrons are readily available, then this is good base. And if this group is electron withdrawing, then the electronic density of nitrogen will be withdrawn toward that group, and lone pair is not readily available, so this will be weak base. Next is reactivity of carbonyl compound. Reactivity of carbonyl compound. Reactivity of carbonyl compounds I am trying to explain it with the help of example. Here is formaldehyde, and formaldehyde is most reactive among carbonyl compounds. It is the most reactive species. Here is the acetaldehyde, and the last one that I am going to write is acetone. It is acetone. Now look at these three structures. In case of formaldehyde, oxygen is attracting electronic density toward itself, being partial negative, and carbon is partial positive. These are weak electron donating group. So we can say that they have no ability to decrease partial positive charge of the carbon atom. So it will be more reactive species. In this case, CH3 is a stronger electron donating group as compared to hydrogen. So when it creates negative, partial negative and partial positive charge, this partial positive charge will be compensated by this methyl group, decreasing the reactivity of acetaldehyde. And another factor, we can say that methyl is a bulky group, so it can block the coming nucleophile. In this case, when oxygen attracts electronic density toward itself, it becomes partial negative and creating partial positive charge on the carbon atom. But you can see that there are two electron donating group, methyl group, and they push electronic density toward the carbon, making decrease in partial positive charge of the carbon. Now we can analyze that this partial positive charge is greater as compared to acetaldehyde, and this partial positive charge is greater as compared to acetone. Now I think that you have taken the concept of inductive effect. Inductive effect is actually polarity in a bond, polarity of a sigma bond due to the presence of electronegative atom, or due to the presence of any group that has electron withdrawing effect or electron donating effect. And it has some applications that I have discussed in this video lecture, and it is the first topic of PPSC lecture test, chemistry. Subscribe my channel and share my videos to others. Thank you and Allah Hafiz.